Okay, for topic three, we're going to look at the Pythagorean identities, and this one is really important. And there are three parts to it, but truthfully, if you can memorize one part and know how to manipulate it, you can sort of derive the other two parts. So again, unfortunately, this is just one of those classes where there are so many components, and memorization of some of it is absolutely necessary. So if you can memorize the first one I show you and learn how and understand how to derive the second two, it'll save you a little bit of heartache. Now, when you're talking about Pythagorean, you absolutely must know this. When we're talking about the Pythagorean theorem, and this is all going to be kind of based on the Pythagorean theorem, we have a right triangle. The legs of the triangle are A and B. The hypotenuse is C. And there's a relationship between these three lengths of the triangle. The relationship is if you take the square, or if you take the legs and square them, the sum of that equals the hypotenuse squared. So all of that is kind of a play on this. And in this video, it's going to be a little bit lengthier. We're going to do a lot of kind of proving and deriving things, okay? So, along with the quotient and reciprocal identities, the Pythagorean identities are part of the fundamental identities of trig. So we have this kind of like packet of identities called the fundamental identities of trigonometry, and the reciprocal, quotient, and now the Pythagorean identities are all part of that. So the first one that I really, really want you to memorize is if we have sine squared of theta plus cosine squared of theta, it equals 1. Okay? Now we also have that 1 plus cotangent theta, let me say that again. 1 plus cotangent squared theta equals cosecant squared theta. And we also have tangent squared theta plus 1 equals secant squared theta. Okay? Now, it's helpful if you memorize all three of these, but if you can memorize the first one and understand how to manipulate it, you can derive the other two. So let's go ahead and do that now. Okay? So example 3, I've just called it short answer. So we're going to take that first Pythagorean identity and we're going to do something with it and see what we get. Okay, so I want these to show. There. So it says take sine squared theta plus cosine squared theta equals 1 and divide both sides by sine squared theta. What do you notice? So we've got sine squared theta plus cosine squared theta equals 1. And we're told divide both sides by sine squared theta. So let's divide everything by sine squared theta. Well, sine squared theta divided by itself is just 1, okay? And then you have to remember the reciprocal and the quotient identities. Previously, we talked about the reciprocal and the quotient identities, and we found that there were two quotient identities. So let me scroll up and remind you of those. So the quotient identities are right here. We had that tan theta equals sine theta divided by cosine theta, and cotan theta equals cosine theta divided by sine theta. So if we go back down here, notice right here we have this relationship where we have cosine divided by sine. Okay, well, if we have cosine squared divided by sine squared, we know the relationship between cosine and sine in this case is going to be cotangent. Okay, so cosine divided by sine is cotangent. So that tells me that cosine squared divided by sine squared is cotangent squared theta. Now, we also had the reciprocal identities. Okay, so the reciprocal identities told us that cosecant is equal to 1 over sine. So let's go back down here. Notice we have this relationship. We have 1 over sine squared. Well, that's going to show some kind of reciprocal relationship with cosecant. So this ends up being cosecant squared theta. And if we look at this right here, it's exactly what we have right here. So if you can take the first Pythagorean identity and divide all parts by sine squared theta, you get the second the second Pythagorean identity. Now, you could also play around with this one. If you wanted to, you could solve this for cotangent. So you could say, okay, cotangent squared theta is equal to cosecant squared theta minus 1. Just subtract 1 from both sides, okay? They're the same thing at the end of the day. All right, now for part B, I actually have a typo here. I just noticed this should say part B, okay? It says take sine squared theta plus cosine squared theta equals 1, but this time divide everything by cosine squared theta, and let's see what happens. So we have sine squared theta plus cosine squared theta equals 1. Let's memorize this one. This one comes up a lot. We need to know this one, okay? Now, if I take and divide everything by cosine squared theta, let's see what happens. Well, sine squared theta, cosine squared theta. So that reminds me of those quotient identities. So let's see if we can trigger something here. So we know that tangent, there's a relationship between tangent, sine, and cosine. And the relationship is that tangent is equal to sine divided by cosine. So if we go back here, we have sine squared divided by cosine squared. Well, that's fine. That just tells me the relationship here is tangent squared theta. Okay? Now, cosine squared theta divided by itself, that's just 1. And then I've got 1 over cosine squared theta. So hopefully these reciprocal and quotient identities are starting to stick a little bit. But if we go back up here, we have that when we're dealing with cosine, we know that secant theta is equal to 1 over cosine theta. Do we see a relationship that looks like this? Well, when we scroll down, we absolutely do. We have 1 over cosine squared theta. Well, that just tells me this is equal to secant squared theta. So let's look at the Pythagorean identities. And this right here looks an awful lot like this. They're the same. So again, if we can memorize sine squared theta plus cosine squared theta equals 1, and then know how to manipulate that, you get the other two Pythagorean identities for free. Okay, so here's the second or the third Pythagorean identity, and we could solve this for tan squared. We could say tangent squared theta equals secant squared theta minus 1. You could also, well, we've already got secant squared. So we know secant squared theta, what it equals. We know tan squared theta, what it equals. We know what cotan squared theta equals. We know what cosecant squared theta equals. The last two that you might want to play around with is if I have sine squared theta, and so we know that we have sine squared theta plus cosine squared theta equals 1. If I wanted to solve for just sine squared theta, well, I would subtract cosine squared theta from each side. So sine squared theta is equal to 1 minus cosine squared theta. And cosine squared theta is equal to 1 minus sine squared theta. So just know you can take these three identities and you can solve for a piece of them and get more, okay? But as long as you can memorize sine squared theta plus cosine squared theta equals 1, that's going to take you a long way. Okay, let's look at example 4. So example 4 is a little tricky. There. So it says, use the Pythagorean theorem and the following triangle to prove each of the following. Okay, now we've got a right triangle here. And remember, the Pythagorean theorem says a squared plus b squared equals c squared. So we know what c squared equals. Now, if I were to take this and subtract b squared from both sides, I would get c squared minus b squared equals a squared. And if I were to take what I originally started with and subtract a squared from both sides, I would get c squared minus a squared equals b squared. So we've taken the Pythagorean theorem and we've solved it for c, a, and b squared. Okay, so c squared, a squared, and b squared. So keep that in mind. That's going to be helpful in just a bit. Now, when it comes to proving things, I'm not going to do this in a super formal way. We're just going to kind of show that these relationships really are true. Okay, now remember SOHCAHTOA. That's going to help us here in just a bit. All right, so we have, for part A, we want to prove that sine squared theta plus cosine squared theta really truly does equal 1. Well, let's look at this triangle. We've got sides A, B, and C, okay? Let's figure out using the ratio of these sides what sine would be. Well, we know sine is opposite over hypotenuse. So opposite is B, hypotenuse is C, and we want to square that. Now, cosine is adjacent over hypotenuse. So in this case, adjacent is A, hypotenuse is C. We want to square that. Now, if we can manipulate this and get this down to a point where it equals 1, we've shown that sine squared theta plus cosine squared theta really does equal 1. Okay, so let's play around with this. So if I have a fraction in parentheses squared, that exponent just applies to both parts of the fraction. So this is really b squared over c squared. And then a over c squared is really a squared over c squared. Now, we also know that if we have common denominators, we can easily add numerators, okay? So this is really equal to b squared plus a squared over c squared. Well, let's come back up here. Notice if we take a squared and add it to b squared, it's equal to c squared. And this numerator is a squared plus b squared. So this tells me right here, this is really just c squared. So I get c squared over c squared, which is, ta-da, 1. So hopefully if that doesn't excite you, good Lord, I don't know what to tell you, but that's really cool. We were able to prove this Pythagorean identity. So let's follow that up with the other two Pythagorean identities. Okay, so for part B, let's play around with this a little bit. Let's say we want to solve this for 1. So we want to say, okay, 1 is equal to cosecant squared theta minus, let me put a minus in there, minus cotan squared theta. So let's prove that this really equals 1, okay? So remember, when you're dealing with cosecant, it's the reciprocal of sine. So we know that sine is opposite over hypotenuse. Therefore, cosecant is hypotenuse over opposite, okay? And when we're looking at this right triangle, we know where theta is. We can say that cosecant is going to be c over b. So c over b, and we need to square it because we've got cosecant squared. Now from that, we want to subtract cotangent. Now we know that cotangent is the reciprocal of tangent, and tangent we have is opposite over adjacent. So that tells me that cotan is going to be adjacent over opposite, okay? So if I look at the adjacent side, that's a compared to theta over c. Opposite. I lied to you. It's adjacent over opposite. Opposite is b. So we get a over b squared. So let's do a little work here. We know that if we have a fraction in parentheses squared, the exponent applies to both parts of the fraction. So we get c squared over b squared minus a squared over b squared. Well, we have common denominators, so we have c squared minus a squared over b squared. Well, let's see if there's a relationship between c squared and a squared. Well, there is. Let me change colors. So c squared minus a squared happens to equal b squared, which is really cool. I think it's really cool anyway. So what we end up getting here is this is equal to b squared. So we get b squared over b squared, which is equal to 1. So we were able to prove the second Pythagorean identity. Okay, now for part C, we have tan squared theta plus 1 equals secant squared theta. Let's go ahead and kind of solve this for 1. So to get 1 by itself, I need to subtract tan squared theta from both sides. So that gives me secant squared theta minus tan squared theta. Okay, now we know that secant is the reciprocal of cosine, okay? And we know that cosine is adjacent over hypotenuse. That tells me that secant has to be hypotenuse over adjacent, okay? So when we're looking at this right triangle, we have theta. The side adjacent to theta is A, and then the hypotenuse is C. So we want to get the hypotenuse over the adjacent side. So this is going to equal C over A, and because we have secant squared, we want to square this fraction. Now, tangent, we know, is opposite over adjacent, okay? So when we're looking at theta here, the opposite side is B, the adjacent side is A. So we get B over A squared. So doing just a little basic arithmetic, we're going to get C squared over A squared minus B squared over A squared. Well, we've got fractions with common denominators, so this is C squared minus B squared over A squared. And if you look right here, c squared minus b squared is equal to a squared. So this right here is a squared. So we have the a squared. Let me scroll down just a smidge so I have a little room. We have a squared over a squared, which is 1. So just by understanding a right triangle, understanding these ratios, we've been able to prove, using the Pythagorean theorem, that these Pythagorean identities are absolutely valid. Okay, so I think that's it for this video. The next video, we'll look at using these identities to simplify expressions. Okay.